Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss statistics. In this chapter, we are going to discuss the concepts of exercise 15.2. In this exercise, we focus we focus on discussion on finding variance and standard deviation of data. Okay, my children. In the previous class, we have discussed the concepts of exercise 15.1, that is finding mean deviation for different kinds of data, that is for ungrouped data, for discrete frequency distribution, for continuous frequency distribution. We have found mean deviation for these kinds of data. I hope you have understood the concepts of mean deviation for different kinds of data, that is for ungrouped data, for discrete frequency distribution, and for continuous frequency distribution. I hope you have learnt well the problems related to mean deviation. Haven't you, my children? Right. In this exercise 15.2, we completely focus on finding variance and standard deviation for different kinds of data. Means for ungrouped data, for discrete frequency distribution, and for continuous frequency distribution. Okay, my children, are you ready to listen the class? Right. You know, mean deviation is one of the measures of dispersion, but there are some limitations in measuring the dispersion of the data. Let us discuss what are the limitations of mean deviation. Okay, my children. So, following are some limitations or demerits of mean deviation. First point, in a frequency distribution, the sum of absolute values of deviations from the mean is always more than the sum of the deviations from the median. Therefore, mean deviation about mean is not very scientific. Thus, in many cases, mean deviation may give unsatisfactory results. This is one of the demerit of mean deviation for measuring the dispersion of the data. Okay, my children. And second demerit, in a distribution where the degree of variability is very high, the median is not a representative central value. Thus, the mean deviation about median calculated for such series cannot be fully relied. Okay, my children, this is the second demerit. And the third one is in the computation of mean deviation, we use absolute values of deviations. Therefore, it cannot be subjected to further algebraic treatment. These are the demerits of mean deviation. That is why the importance of variance and standard deviations come to the limelight. Okay, my children, right. To overcome the limitations or demerits of mean deviation for finding the measurement of dispersion of the data, we are finding variance and standard deviation. Okay, my children. Now let us discuss what is meant by variance, how to find variance. Okay, my children. Right. The variance of variate x is the arithmetic mean of the squares of all deviations of x from the arithmetic mean of the observations and is denoted by way of x or sigma square. This is a Greek letter. Okay, my children. So sigma square. The positive square root of the variance of a variate x is known as its standard deviation and it is denoted by sigma. Okay, my children. This is about variance and the standard deviation of a given data. Thus, standard deviation is equal to plus square root of variance of the data. Okay, my children. Similar to the mean deviation, we shall discuss the calculation of variance and the standard deviation in the following three cases. Individual observations means for ungrouped data, and the second case for discrete frequency distribution, and the third case continuous or grouped frequency distribution. In all these three cases, we are going to discuss to find the variance and the standard deviation of the given data. Okay, my children, right. Now come to this point, my children, variance of individual observations. This is nothing but finding the variance of ungrouped data. Okay, my children, right. If x1, x2, and so on xn are n values of a variable capital letter X, then variance of x is equal to 1 by n into sigma I is equal to 1 to n xi minus x bar whole square, or sigma square is equal to 1 by n into sigma I is equal to 1 to n xi minus x bar whole square. Both are denoting the variance of the given data for a ungrouped data. So this formula also can be written as variance of the data is equal to 1 by n sigma I is equal to 1 to n xi square minus 1 by n sigma I is equal to 1 to n xi whole square. We can use this formula or this formula. Both gives the same result. Okay, my children, right. So to find the variance of individual observations, that is for ungrouped data, to find the variance of a ungrouped data, we use the following algorithm, which is useful for finding variance when deviations are taken from actual mean. Okay, my children, right. Step 1. Compute the mean x bar of the given observations. Okay, my children, we have to find mean of the given ungrouped data. Okay, my children, do you know how to find the mean of the ungrouped data? Yes, sum of the observations by number of observations. By using that formula, we have to find the mean of the given ungrouped data. And the second step, take the deviations of the observations from the mean, that is xi minus x bar. As we have found the deviations from the mean, in the case of mean deviation, here also we have to find the deviations of the observations from the mean. Okay, mentioned this is the second step. Now third step, in the case of mean deviation, we have taken absolute values of deviations, but here in this case of variance, we had to square the deviations obtained in step 2. We have to find the square of each deviation, and that is sigma I is equal to 1 to n xi minus x bar whole square. Okay, my children, understood this point? In the case of mean deviation, we have found sigma I is equal to 1 to n modulus of xi minus x bar, whereas here we are finding the sum of the squares of the deviations from the mean. Understood? This is the third step, my children. Right. Now come to the fourth step. Divide the sum sigma I is equal to 1 to n xi minus x bar whole square obtained in step 3 by n, that is number of observations. This gives the value of variance of the ungrouped data. Understood these steps, my children? Right. Let us take an example for finding the variance and the standard deviation of individual observations. That means finding variance and the standard deviation of ungrouped data. Okay, my children, right. Compute the variance and the standard deviation of the following observations of marks of 5 students of a tutorial group. See this data, my children. Out of 25 marks out of 25, first student got 8, second 12, third student 13, fourth student 15 marks, and the fifth student got 22 marks. Okay, my children. So for this data, if you observe this data, this is ungrouped data. This is also called individual observations. For this data, we have to find variance and standard deviation. What is the first step, my children? X bar. We have to find mean of the given data. So sum of the observations by number of the observations. So 8 plus 12 plus 13 plus 15 plus 22 whole divided by number of observations 5. Okay, my children, understood this step? Right. That is equal to, by simplifying this number, we get 14. This is the mean of the given ungrouped data. Understood this step, my children? Right. Now let us prepare a table. Here xi, that is observations, individual observations, 8, 12, 13, 15, 22. Okay, my children. Now let us find deviations from mean. As we have found in the case of mean deviation, here also we have to find deviations of the observations about mean. So xi minus x bar. So 8 minus 14, we got a minus 6. 12 minus 14, we get a minus 2. Understood these points, my children? 13 minus 14, we get a minus 1. 15 minus 14, we get a 1. 22 minus 14, we get a 8. Understood all these deviations, my dear children? Right. After finding the deviations, we have to find the squares of these numbers. So minus 6 whole square, what will you get? 36. Minus 2 whole square, what will you get? 4. Minus 1 whole square, what will you get here? 1. 1 whole square, what will you get here? 1. 8 whole square, what will you get here? 64. Understood all these 6 values, my dear children, in this column. Right. After finding all these values, we have to find total sum of all these 6 values. That is 36 plus 4 plus 1 plus 1 plus 64. What will get here? 106. Understood this number, my children? Right. So here n is equal to 5. Number of observation is equal to 5. And we found sigma I is equal to 1 to n xi minus x bar whole square. That is equal to 106. Okay, my children. Therefore, variance is equal to 1 by n into sigma xi minus x bar whole square. That is equal to, in this formula, let us substitute these two values. So 106 by 5. That is equal to, by simplifying this number, what will you get? 21.2. This is the variance of the given ungrouped data. Okay, my children. Then standard deviation is equal to square root of the variance of the given data. That is equal to square root of 21.2. That is equal to, what is the square root of 21.2? 4.604. You have to find the square root of 21.2 by division method. Do you remember that method, my dear children? Right. Now come to the second type of the data. Standard deviation of discrete frequency distribution. Okay, my children. In the previous point, we have discussed finding the variance and the standard deviation of ungrouped data or for individual observations. Now, we are going to discuss variance and standard deviation of a discrete frequency distribution. Without finding the variance, we can't find the standard deviation. Okay, my children, because sigma is a square root of the variance. So, now, my children, right. Now, let the given discrete frequency distribution be x free f frequencies, x1, x2, x3, and so on, xn, and their respective frequencies are f1, f2, f3, and so on, fn. This is the discrete frequency distribution. To find the standard deviation of this discrete frequency distribution, we use this formula. In this case, standard deviation sigma is equal to square root of 1 by capital letter N into sigma I is equal to 1 to N Fi into xi minus x bar whole square. Okay, my children, where capital letter N denotes sum of the frequencies, that is sigma I is equal to 1 to N Fi. Understood this point, my children? Right. To understand this point well, to understand this concept well, let us take up the following example. Okay, my children, find the variance and standard deviation for the following data. This is a given discrete frequency distribution because only xi's and fi's are given. 4, 8, 11, 17, 20, 24, 32. And their respective frequencies are 3, 5, 9, 5, 4, 3, 1. Okay, my children. So for this discrete frequency distribution, we are going to find variance and standard deviation. Okay, my children. Right. Let us write xi's 4, 8, 11, 17, 20, 24, 32. After that, fi's frequencies 3, 5, 9, 4, 5, 4, 3, 1. After writing this table frequencies, let us find sum of the frequencies. That is 3 plus 5 plus 9 plus 5 plus 4 plus 3 plus 1. What will we get here? 30. Sum of the frequencies is 30. Okay, my children, understood this point? Right. Now come to the next column, Fi into Xi. We have to prepare this column, Fi into Xi. So 4 3s are 12, 8 5s are 40, 11 9s are 99, 7 5s are 85, 24s are 80, 24 3s are 72, 32 1s are 32. Understood all these 6 values, my children? 1, 2, 3, 4, 5, 6, 7, all 7 values. After finding all these 7 values, let us find their total. That is 12 plus 40 plus 99 plus 85 plus 80 plus 72 plus 32. What will you get here? 420. Okay, my children. This is Fi into Xi. After finding this value, let us find mean. How do you find mean? Yes, sigma Fi Xi by sigma Fi. Do you remember that formula, my children? So 420 by 30. What will get here? Yes, 14. Yes, my children. 14 is x bar. That is the mean of the given discrete frequency distribution. So now let us prepare xi minus x bar, that is deviations about mean. We are finding here deviations of the observations about mean. So 4 minus 14, what will get? Minus 10. 8 minus 14 minus 6, 11 minus 14 minus 3, 17 minus 14 3, 20 minus 14 is equal to 6, 24 minus 14 is equal to 10, 32 minus 14 is equal to 18. Understood these 7 deviations about mean, my dear children, right? After finding the deviations, we have to find their squares. In the case of mean deviation, we have found here their magnitude. Do you remember that point, my dear children? But in this case of variance and standard deviation, we have to find squares of these deviations. Okay, my children. So minus 10 whole square gives 100, minus 6 whole square gives 36, minus 3 whole square gives 9, 3 whole square is equal to 9, 6 whole square is equal to 36, 10 whole square is equal to 100, 18 whole square is equal to 324. Understood all these 7 values, my dear children? Right. Now we have to find fi into xi minus x bar whole square. In the case of mean deviation, we have found fi into modulus of xi minus x bar. Yes or no, my children? But here we have to find fi into xi minus x bar whole square. We have to multiply these two values. So 3 into 100 is equal to 300. 5 into 36 is equal to 180. 9 into 9 is equal to 81. 5 into 9 is equal to 45. 4 into 36 is equal to 144. 3 into 100 is equal to 300. 1 into 324 is equal to 324. Understood all these 7 values, my dear children? Right. After finding these values, let us find the total sum of all these 7 values. That is 300 plus 180 plus 81 plus 45 plus 144 plus 300 plus 324. What we get here? 1374. Understood this number, my dear children? Right. So here capital letter N, it means sum of the frequencies, that is equal to 30. We have found sigma is equal to 1 to 7 fi xi, that is equal to, we have got 420. Sigma I is equal to 1 to n fi into xi minus x bar whole square. We got 1374. Okay, my children. Here in this step we have found mean of the observation, mean of the given data, that is 14. Previously I told you mean of this discrete frequency distribution is 14. So now come to the variance. Sigma square is equal to 1 by capital letter N into sigma I is equal to 1 to 7 fi into xi minus x bar whole square. So in this formula, let us substitute the values. 1 by capital letter N is equal to 30 into what is the value of sigma is equal to 1 to n fi into xi minus x bar whole square as 1374. Understood this statement, children? Right. By simplifying these two numbers, we get 45.8. Okay, my children. This is the variance of the given discrete frequency distribution. Then standard deviation is equal to sigma is equal to square root of variance. What is the variance here? 45.8. So square root of 45.8. That is equal to 6.77. This is the square root of 45.8. Okay, my children, understood this point? Right. In the previous point, we have discussed the variance and standard deviation of a discrete frequency distribution. Now come to the third case, that is finding the variance and the standard deviation of a continuous frequency distribution. This is the last case. Okay, my children? Right. The given continuous frequency distribution can be represented as a discrete frequency distribution by replacing each class by its midpoint. Yes or no, my children? The continuous frequency distribution can be written as a discrete frequency distribution by replacing the class intervals by their midpoints. Okay, my children. Then the standard deviation is calculated by the technique adopted in the case of a discrete frequency distribution. Okay, my children, we use the same technique. We use the same formula to find the standard deviation of a continuous frequency distribution also. Okay, my children, understood this point? Right. If there is a frequency distribution of n classes, each class defined by its midpoint xi with frequencies fi, the standard deviation will be obtained by the formula sigma is equal to square root of 1 by capital letter N into sigma I is equal to 1 to n fi into xi minus x bar whole square. This is also nothing but the formula for finding the standard deviation of a discrete frequency distribution. We are using the same formula here. Okay, my children. Right. Another formula for finding standard deviation of a continuous frequency distribution. We can use this formula also. Okay, my children. Therefore, standard deviation sigma is equal to 1 by capital letter N into square root of capital letter N into sigma is equal to 1 to n fi into xi square minus sigma is equal to 1 to n fi xi whole square. We can use this formula or this formula. In both cases, we get the same result. Okay, my children. Right. To understand this point well, let us take an example to calculate the variance and the standard deviation of a continuous frequency distribution. Okay, my children, right. Calculate the mean, variance and standard deviation for the following distribution. See this frequency distribution, my children, it is a continuous frequency distribution because here upper limit of the first class interval is equal to the lower limit of the second class interval. Similarly, upper limit of the second class interval is equal to the lower limit of the third class interval. Similarly, upper limit of the third class interval is equal to the lower limit of the fourth class interval and so on. Observe all these class intervals. You get the same. Okay, my children. Right. So, for this continuous frequency distribution, let us find mean, variance and standard deviation. Okay, my children. Right. Let us prepare a table. So, in this first column, let us write the class intervals, classes 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. And their respective frequencies, the corresponding frequencies of each class 3, 7, 12, 15, 8, 3, 2. Okay, my children, 1, 2, 3, 4, 5, 6, 7. Okay, 7 frequencies, 7 classes are given and their respective frequencies, 7 frequencies are given. Let us find the sum of the frequencies. That is equal to sigma I is equal to 1 to 7 fi. That is 3 plus 7 plus 12 plus 15 plus 8 plus 3 plus 2 gives 50. Understood this number, my children? Right. Now come to the point. Midpoint. In this column, we prepare midpoint. Okay, my children. Right. What is the midpoint of this class? Yes. Lower limit plus upper limit by 2. 30 plus 40. What will you get? 70. 70 by 2. What you get here? 35. Okay, my children. Here, the class size of each class interval is 10. So, just to add 10 to the first midpoint. We get a second midpoint, 35. And add 10, 55. And add 10 to this number. We get to 65. Add 10 to this number. Plus 75. 75 plus 10, 85. 85 plus 10, 95. Understood all these 7 values, my children? Right. After that, we follow the same procedure as we follow the same technique as we followed to find the variance and standard deviation of a discrete frequency distribution. Okay, my children. So we have to prepare this column Fi into Xi. So 3 into 35, that is equal to 105. 7 into 45 is equal to 315. 12 into 55, that is equal to 660. Okay, my children. 15 into 65 is equal to 975. 8 into 75 is equal to 600. 3 into 85 is equal to 255. 2 into 95 is equal to 190. Understood all these 7 values, my children? Right. After finding all these 7 values, let us find the total sum of these values. So 105 plus 315 plus 660 plus 975 plus 600 plus 255 plus 190, that is equal to 3100. Understood this number, my children? Right. After finding these two values, let us find mean of these frequency distribution. How do you find the mean of the frequency distribution? Sigma Fi Xi by sigma Fi. Do you remember that formula, my children? Right. That is equal to 3100 by 50. 3100 by 50. Then what we get here? 300, 0 cancel, 5, 6, 62. Okay, my children, 62 is the mean of this frequency distribution. Remember that point. It will be shown in the next slide. Okay, my children, 62 is the mean of the frequency distribution. So let us find deviations. Here directly we found the squares of the deviations about the mean. Okay, my children. So 35 minus 62 whole square. What we get here? 729. And 45 minus 62 whole square gives 289. 55 minus 62. What will you get here? 49. 65 minus 62 whole square gives 9. 75 minus 62 whole square gives 169. 85 minus 62 whole square gives 529. 95 minus 62 whole square gives 1089. Understood all these 7 values, my children? Right. After that, we have to find this column. We have to prepare this column, that is Fi into Xi minus X bar whole square. Okay, my children. So 3 into 3, 729 gives 2187. 7 into 289 gives 2023. 12 into 49 gives 588. 15 into 9, that is equal to 135. 8 into 169 is equal to 1352. 3 into 529, that is equal to 1587. 2 into 1089 is equal to 2178. Understood all these 7 values, my children? Right. After finding all these 7 values, let us find the sum of all these 7 values. That is 2187 plus 2023 plus 588 plus 135 plus 1352 plus 1587 plus 2178 gives 10,050. Understood this number, my children? Right. So mean of the given frequency distribution, we have already found 62. In the previous slide, I have explained that one. 3100 by 50 gives 62. Okay, my children. After that, variance is equal to sigma square is equal to 1 by capital letter N into sigma I is equal to 127 Fi into Xi minus X bar whole square. In this formula, let us substitute the values. 1 by capital letter N, that is sum of the frequencies, that is 50 into, we have found the value of this number sigma is equal to 1 to n fi into xi minus x bar whole square, that is 10,050. Understood this statement, children? Right. Now let us simplify these two numbers. What will get? 201. This is the variance of the given continuous frequency distribution. Understood this point, my children? Right. Then standard deviation sigma is equal to square root of the variance. What is the variance here? 201. So square root of 201. Then find the square root of 201 by division method. Then what will you get here? 14.18. Okay, my children, understood this point? Right. There is a shortcut method to find variance and standard deviation. Okay, my children? Right. Let us discuss that point here. Sometimes the values of xi's in the discrete distribution or the midpoints xi's of different classes in a continuous distribution are large, and so the calculation of mean and variance becomes tedious and time consuming. Okay, my children, the values of xi's are very large numbers, then it takes more time to calculate mean of the distribution and variance of the distribution. So by using step deviation method, it is possible to simplify the procedure. So here we use a step deviation method to find the variance and standard deviation of a continuous frequency distribution. Okay, my children, right. Let us discuss that method, shortcut method. Let the assumed mean be capital letter A and the scale be reduced to 1 by h times. Here h being the width of the class intervals. Okay, my children, here h denotes width of the class intervals. Let the step deviations or the new values of yi, standard deviation is equal to h by capital letter N into square root of capital letter N into sigma is equal to 1 to n fi into yi square minus sigma I is equal to 1 to n fi into yi whole square. Okay, my children, understood this point? Step deviation method to reduce the time to find the variance and the standard deviation of a given frequency distribution. Okay, my children, right. To understand the point well, let us take an example. To calculate mean, variance and standard deviation of a given continuous frequency distribution by using step deviation method. Okay, my children, right. See this continuous frequency distribution. The previous question only, previous example, same previous example we have taken here. So we are preparing the table here. Let the assumed mean A is equal to 65. Here h is equal to 10. Width of the class intervals. What is the width of the class intervals? 40 minus 10. 40 minus 30 gives 10. That is the width of the class intervals. Okay, mentioned here we have assumed the mean is 65. Assumed mean is taken as 65. In general, we take middle point, midpoint of middle class, midpoint of the middle class. Okay, my children. In general, we take that number as assumed mean. Okay, my children. Right. Now let us prepare a table. In this first column, we write class intervals, and in the second column, we write their respective frequencies. After that, we find the sum of the frequencies. We got here 50. Understood this 50, my children? Right. After that, we find midpoint of the class intervals. As we have found the midpoints of the class intervals, here also we find the midpoints of the class intervals. Understood this column, my children? Right. After that, here we are finding step deviation. Okay, my children. yi is equal to xi minus 65 by 10. To reduce the time consuming, we are using this step deviation method. Okay, my children. So we are finding yi's by using this formula xi minus assumed mean by h. Understood this point, my children? So we prepare this column. So xi 35 minus 65 by 10. What you will get here? Minus 3. Understood this number, my children? Right. Similarly, 45 minus 65 by 10. We get to minus 2. Similarly, 55 minus 65 by 10. We get to minus 1. Similarly, 65 minus 60 by 10. We get to 0. Similarly, 75 minus 65 by 10, that is equal to 1. Similarly, 85 minus 65 by 10, that is equal to 2. Similarly, 95 minus 65 by 10, what you will get here? 3. Understood these deviations, my children? Right. After finding these deviations, we have to find their squares. Yi square minus 3 whole square, that is equal to 9, minus 2 whole square, that is equal to 4, minus 1 whole square, that is equal to 1, 0 square is equal to 0, 1 whole square is equal to 1, 2 whole square is equal to 4, 3 whole square is equal to 9. Understood these 7 values, my children? Yi square. Right. After that, here we have to prepare new column, that is fi into yi. Not fi into xi. Okay, my children, we are finding fi into yi. So 3 into minus 3, we get minus 9. 3 into minus 2, that is equal to minus 14. 12 into minus 1, we get a minus 12. 15 into 0, we get a 0. 8 into 1, we get 8. 3 into 2, we get a 6. 2 into 3, we get a 6. Understood all these 7 values, my children? Right. After finding these 7 values, let us find the sum of all these 7 values. That is minus 9 plus minus 14 plus minus 12 plus 0 plus 8 plus 6 plus 6. What will get here? Minus 15. Understood this number, my children? Right. After that, here we have to prepare a new column, that is fi into yi square. The previous method we have found fi into xi square, but here we are finding fi into yi square. Okay, my children? Right. So 3 into 9, we get 27. 7 into 4, we get 28. 12 into 1, we get 12. 15 into 0, we get here 0. 8 into 1, we get 8. 3 into 4, we get here 12. 2 into 9 is equal to 18. Understood all these 7 values, my children? Right. After finding all these 7 values, let us find the total sum of all these 7 values. That is 27 plus 28 plus 12 plus 0 plus 8 plus 12 plus 18. What will get here? 105. Understood this number, my children? Right. Now let us find the mean of the given distribution, that is xi bar is equal to a plus sigma fi into yi by 50 into h. Okay, my children, by using this formula, we are finding the mean of the given distribution, that is equal to 65. We assumed here, this is assumed mean, that is 65 minus sigma fi into yi. What we got here? Minus 15 divided by 50 into what is the value of h? 10. Okay, my children, understood this step? Right. Now simplify these numbers. What will get here? 62. Understood this number, my children? 62. Right. Now variance. Sigma square is equal to h square by capital N square into capital letter N into sigma fi into yi square minus sigma fi into yi whole square. Okay, my children? This is the formula. Do you remember this formula, my children? In the step deviation method, to find variance of continuous frequency distribution, right? So in this formula, let us substitute the values. H square, that is 10 square by capital N whole square, that is 50 whole square, into capital letter N value is 50, into we have found sigma Fi into Y square 105, minus sigma Fi into Yi, that is minus 15 whole square. Understood this statement, children? Right. Now let us simplify these numbers. What will get here? 10 by 5, then 10 by 50, 1 by 5 whole square, that is 1 by 25. Understood this number, my children? Into 50 into 105, what will get? 5250 minus 15 whole square, what will get here? 225. Understood this step, my children? Right. Now by simplifying this number, what will get here? 201. Understood this step, my children? Right. This is the variance of the given frequency distribution by step deviation method, by shortcut method. Okay, my children? Right. Now standard deviation, sigma is equal to square root of variance. What is the variance of the data? 201. So square root of 201. Understood this step, my children? Right. That is equal to 14.18. Understood this point, my children? Right.